Welcome to Construction Math. Today we're going to be talking about solving systems of equations by graphing. So on your note taker, I want you to be able to answer this question after you think about the definition of the term intersection. And it doesn't have to be in math terms. What's the definition? What do you know about an intersection? Write your definition on your note taker or draw a picture and share it with your partner. Teacher, pause the video and then call on non-volunteers. And I'll meet you back here in a minute. Welcome back. Intersection, a couple of things if you went with the idea of roads. An intersection is a place where two or more roads meet. It's a geometric figures that have points in common. Or it can be a set consisting of all the members that belong to two or more sets. If I have the set 1, 3, 5 and the set 3, 4, 5, 6, 3 and 5 are the intersection of those two sets. So whichever of the three definitions you went with is fine. All right, math check. Two things I need you to do. I need you to graph the line y equals 3x minus 1, and then I need you to graph the line y equals 2x plus y equals 5. Teacher, pause the video and have students graph these lines on their note taker, and I'll meet you back here in a minute. Welcome back. Let's go to our slate, and let's see about graphing these. All right, so the first one is y equals 3x minus 1. Remember when you graph, you need it to be in the form of y equals mx plus b so that we can get the information out. First of all, m is 3. That means the slope is 3, which means slope is rise over run. So I use a rise of 3 and a run of 1. This number without a variable on it is called the y-intercept. And that's where the graph hits the y-axis. So my y-intercept is -1. So let's do a quick sketch. Hopefully on your note taker, using the graph is a little easier than what I've got here. All right, so it says the y-intercept is -1, so I put a dot at y equals -1. From there, the slope is 3 over 1. So from this point, I rise 3, 1, 2, 3, and I run 1. Remember, runs positive go to the right, negatives go to the left, and then I draw a line through the 2 points. And there's my line. Not too difficult when it's in that form. The second example said 2x plus y equals 5. The first thing you have to do is solve it for y to get it in this format. So the first thing I'm going to do is subtract 2x from both sides. So I get the equation y equals -2x plus 5. That tells me again, this is the m, this is the b. So my slope is -2. Make it a fraction. I'm going to choose to make it -2 over 1. The y-intercept is 5, and I used b. So let's go ahead and make my graph. 1, 2, 3, 4, 5, 2, 3, 4. Just put some tick marks here, hoping to make them as reasonably equal as possible. So the y-intercept is 5. So I go up to where y is 5 and put a dot. The slope is -2 over 1. So the rise and the run. Remember, rise is a vertical. Up is positive, down is negative. Run is horizontal. Right is positive, left is negative. So this says from this point on my y-intercept to go down 2 and right 1. And there's my graph. If you can do this step in the math check, the lesson's going to be pretty easy for you. So teacher, pause the video, have the students have a chance to check and add this to their notes, and I'll meet you back here in a minute. Welcome back. Let's clear this off and go back to our PowerPoint. All right, here's the first one. So this one's much nicer. It looks really nice. The y-intercept was -1. We rose 3, and which meant to go up 3 and right 1, put another dot and draw our line. Here was the second one. And it looks very nice too. I did a lot better doing them with my graphing calculator than I did doing them by hand. So let's go on. Now on your note taker, fill in the missing words. We have 3 objectives today. One is to define terminology. Second one is to explain the steps in solving a system of equations by graphing. And 3, we're going to solve a real world should say construction problem by graphing systems of equations. So we're going to look at construction problems, not auto problems. I apologize. So let's go on. Here's the terminology for today. When we talk about a system of equations, it consists of two or more equations that have the same variable where each equation is going to represent a line. In this lesson today, we're going to only look at two equations to find out where they match. We're going to look at and have you complete your vocabulary square on your note taker. Have the students share their meaningful sentence, and I'll meet you back here in a few minutes. Welcome back. Let's go on. Here's a construction problem. Al has twice as many calls for roof repairs as Bob does. Obviously, they're both roofers. The cost of each of Al's repairs was $200, and the cost for each of Bob's repairs was $100. The combined cost for all the repairs was $1,000 for Monday. How many of roof repairs did each foreman make? All right, so that's what we need to find out. So in this lesson today, this is what we're going to have to go ahead and find out how to solve. Fill in the missing values on your note taker, and I'll meet you back here in a minute. Welcome back. Let's look. Steps to solve a system of equations. First of all, we're going to identify the important information. We're going to define the two variables, x and y usually. 3, we're going to write two equations, and we're going to select a method to solve. By the end of this year, I'm going to teach you several methods, but today we're going to use the graphing method, and I'm going to teach you when it's most appropriate. So fill in the missing words, and I'll meet you back here in a minute. Welcome back. So first thing is I want you to go back to that original problem and underline the important information about Al and Bob, and I'll meet you back here in a minute. Welcome back. Let's look at this. We're going to look at two variables with two equations. So in order to solve, we can use graphing, substitution, and the eliminate. And I've taught math for a lot of years, and we always call it graphing. We always call it substitution. The elimination method or the addition method has several names besides elimination or addition. It could be the sum method. So we'll be calling it either elimination or addition. So no matter what method you use on the same problem, it should come up to be the same answer. We're going to always have an ordered pairs, an x and a y, and you're going to want to make sure that you label your answers. So fill in the missing words in your note taker, and I'll meet you back here in a minute. Welcome back. Now, steps in the graphing method. First of all, you always want to take your equation and rewrite it in slope-intercept form, like we did on the math check. You always want to solve the equation for y because it makes graphing so much easier. Step number 2 is we're going to graph each line, and step number 3 is we're going to identify the point where these two lines intersect, or the intersection. So fill in the missing terms, and I'll meet you back here in a minute. Welcome back. So what I want you to do is think about those 3 steps and summarize it in your own words. Share with your partner and teacher call on non-volunteers. And I'll meet you back here. Welcome back. You shared. So here's what it's going to look like. I have graphed with my graphing calculator 2 different lines. I graphed the line y equals negative x plus 4. Y equals negative x plus 4 is the blue line. I can tell it's the blue line because it has a negative slope, which means as I read from left to right, it's going to go down in value. The red line is the y equals x minus 1. And when you find the point of intersection, it's where those two cross, so that I get the ordered pair x equals 3 and y equals 1 in that particular graph. And so you always read the x value first and then the y. So the first thing is, can you read an ordered pair? That's step 1. It's 2 and 3. We've done it all. So what was the point of intersection of this line? So teacher, pause the video and have the students figure out what this point of intersection is. Right now it doesn't matter what the equation of the line is. Just find the ordered pairs. Have them share with their partner and call on non-volunteers. Welcome back. Here's what I got. X was 5 and Y was 3. That was the point of intersection. All right, so now that we know that we can read off the answer from a graph, how are we going to get there? So let's look at this example. This, I don't want you to do any math other than just figure out the two numbers. I want you to find two numbers that when you add them together, the sum is 8, but when you subtract them, they equal 2. So find out what the two numbers are. Pause the video, and I'll meet you back here in a minute. Welcome back. Let's see what you got. I got 5 and 3, and they had to be in this order because 5 plus 3 is 8. I know that 3 plus 5 is also 8, but when I subtract them, they had to equal to 2. 5 minus 3 is 2. 3 minus 5 is not equal to 2. It's equal to -2. So we're going to use this example that we already know the answer to learn how to graph it. All right, so let's look at this. We want to solve this system. Think of the two numbers. I always am going to write a legend. I'm always going to say what X and Y is equal to. In this case, we're not talking about roots. We're not talking about Allen Bob. We're just talking about two numbers. So I'm going to let X equal the first number and Y equal the second number. All right? So then let's go to our slate and let's see what I can do with this problem. Let me just flip over in my notes, and I'm going to let X equal the first number and Y equal the second. So X equals the first number, and Y is going to equal the second number. All right, so it said the sum of the two numbers was equal to 8. X plus Y equals 8. The difference was equal to 2. And we want to solve both these equations. So the first thing I want to do is get each one in slope-intercept form. I want to solve it for Y. So let's take the first equation. I'm going to subtract X from both sides. So I get Y equals -X plus 8. Second one was X minus Y equals 2. I'm going to subtract X from both sides. I get -Y equals -X plus 2. I'm going to divide everybody by a -1 or take the opposite of everybody's sign because Y has to be positive. A negative divided by a negative is a positive, so that just gives me 1x. A positive divided by a negative is a negative. Here are my two equations that I'm going to graph. All right, so pause the video until everybody's gotten that done. Welcome back. Let's go ahead and look at our graph. So I'm going to try to make a fairly nice graph. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's make it longer. 8. All right, in this one, my slope. Notice there's no coefficient. It's just a negative sign. So that to me means -1, which means rise over 1 means -1 over 1. The y-intercept is 8. So I'm going to put a dot at 8. I'm going to go down 1 and right 1. And I'm going to do it a couple times so I can get a fairly decent graph. Here we go. This one, the y-intercept is +1. I'm sorry, the slope is +1. There's no coefficient out here. It's positive. So I put 1 over 1. The y-intercept is -2. So I go to y equals -2. I go up 1 over 1, up 1 over 1, and then draw the line. And even though my graph is pretty shaky, because this is hard to graph on, let's see where my point crosses. 1, 2, 3, 4. It's about 5. This looks like about 5, 4, but I know the real answer is 5, 3. My graph is just a little bit off. So I double check it. Luckily on your note taker, I've added graph paper or coordinate points. So pause the video, make sure it's okay. On a test, if you really came out with this answer and put 5, 4, and it looks like it from your graph, I would still give you, I would still count it correct. All right, pause the video. Students need more time. Let's go back to our PowerPoint, and let's look. I set up the equations. I solved each one of these for y. I'm going to graph them, And here I did it with my graphing calculator, and it sure looks a lot better. That time it really, really, really hit on the 0.53. Excellent. All right. So now we're going to go to the next one, and here's a you try. You try this one. Remember the steps, copy down the problem, solve it for y, graph, and show me where they intersect. Have your teacher pause the video, and we'll meet you back here in a couple minutes. Welcome back. Let's look. I solved each one for y. So the first equation, I got y equals negative 2x plus 1. That tells me the slope is negative 2, so it's negative 2 over 1. The second one, I came up with a lot of fractions. I got y equals negative 1/2 x minus 1/2. The slope is negative 1/2. What I have to do on that one is I have to decide whether I want the negative to be in the numerator or the denominator. I think I'm going to put it in the numerator and make the rise over 1 negative 1 over 2, and the y-intercept is at negative 1/2. When you graph it, this is what it looks like. All right? My red line was the one where y equals negative 1/2 x minus 1. And then the next step was to find out where they crossed. They crossed, the intersection point was 1, negative 1. That's your answer. X is 1, y is negative 1. Now, let's go back to the problem that we looked at. You've already underlined the important information. So let's go ahead and see if we can solve it. We've underlined the important information. If you didn't, find it in your note taker. All right, so Al has twice as many calls as Bob. Don't care that it was really a roof. Al's repairs were $200, Bob's cost $100. They combined, and remember combined means to add. How many of each roof repairs did each foreman make? All right, so the first thing I want you to do is set up what x equals and what y equals. Because we want it to be on the graph, and it makes more sense to have an x, y, although we have Al and Bob. And then see if you can set up the two equations. All right, teacher, pause the video, and I'll meet you back here in a minute. Welcome back. Here's what I got. I said X was Al's repairs and Y was Bob's repairs. X was Al's. Al's had twice as many as Bob, so X equals 2Y. Now, Al's repairs were 200 times the number of repairs he made, plus 100 times the number of repairs Bob made, and it had to equal $1,000. Remember, the 200 and the 100 stand for money. Now, take a minute, solve each one of these for Y in your note taker, and I'll meet you back here when you're finished. Teacher, pause the video. Welcome back. Let's see if you did it correctly. Now, to solve the first one for y, I had x equals 2y. I needed to solve both sides by 2, or divide both sides by 2, so that I got 1y, and I wrote that first. Remember that x standing there is 1x, so it became 1/2 x. The other one was a little bit easier. The numbers were big, but I moved the 200x to the other side by subtracting 200x from both sides. So I got 100y equals negative 200x plus 1,000. I divided everybody by 100 and got y equals negative 2x plus 10. So on your note taker, would you graph these two? Now remember, this is a real life problem. Neither Al nor Bob can do negative numbers of jobs. So we know that both x and y better come out to be positive. And for this problem, they'll probably turn out to be a positive number because it wouldn't make very much sense to do a half a job. All right, so pause the video until the students have had a chance to graph these. Welcome back. Let's go to my graph and see. All right, y equals y equals, what was it? Let me get back and see my notes. Y equals 1/2 x, so that's the blue line. The y-intercept was at 0, so I put a dot at the origin. The slope was 1/2, so I went up 1 and right 2 and put a dot and then drew my line. The second equation was y equals negative 2x plus 10. So I went up to y equals positive 10. I went down 2 and right 1 and put a dot and then drew the line. And then I found that the point of intersection was x equals 4 and y equals 2. And we need to find out what that means. All right? So think about what that means. If you know, write it down on your note taker. Let's go on and see what it means. Remember, X was the number of Al's repairs. So X was 4. So Al did 4 repairs. Bob was 2. And so Bob did 2 repairs. And these all happened on Monday. Excellent. So now you try this one. You're using PVC pipe. A piece of PVC is 30 inches long and is cut into 2 pieces, with one part being 4 times the length of the other. How long were each of these pieces? All right. So teacher, pause the video, have students work with their partners, and I'll meet you back here in a minute. Welcome back. Let's go to our slates and see what we can do about this problem. First of all, we've got 2 pieces of the PVC. I'm going to let X, just by my choice, be the smaller piece. I find in most cases it's easier to make X the smaller piece and Y the larger. If you did it the other way around, it doesn't really make any difference. All right, it says together these pieces equal to 30 inches. So X plus Y equals to 30. That was the first piece I knew. The second piece that said that the smaller or the larger piece was 4 times the smaller. So here are my 2 equations. All right, so if you need to ask the teacher to pause the video if you need a chance to solve these each for Y, now that you have the right equations. Welcome back. Let's take them and solve them for Y. So X plus Y equals 30. Subtract X from both sides. So Y equals negative X plus 30. That tells me the slope is negative 1, because remember, if it doesn't have a coefficient, it's a 1. I put it in rise over 1, negative 1 over 1. The y-intercept was 30. Now here, all I have to do is change the order and change it to y equals 4x. So the slope is 4, which means rise over run is 4 over 1. And the y-intercept, notice there's no extra number here, is 0. All right? So we're going to have to graph it. So here in the first one, the slope is negative 1 over 1, and the y-intercept is 30. Here the slope is 4 over 1, and the y-intercept is 0. Instead of making a mess out of it, I'm going to give you a chance to do it, then I'm going to go back to my PowerPoint. Welcome back. Let's go back to the PowerPoint where I have a nicer graph. There I've solved them, and here I've graphed them. I had the y-intercept, the red line was 30, and its slope was negative 1, so I went down 1 over 1. Notice the x and y-axis are a little bit different in size. That's because I couldn't fit it on very well and show you what I needed to. The second one was y. The blue line is y equals 4x plus 0, so I put a dot at 0. I went up 4 and right 1, and then now your next step is to find out where those 2 lines cross. So count the number of tick marks, and then write it as an ordered pair. Here we go. It's 4, and remember it was inches, and the y-intercept or the y-coordinate of that ordered pair was 16. So it says the smaller piece of PVC is 4 inches, the larger piece is 16 inches. Now, think about what some advantages and disadvantages are to the graphing method to solve systems of equations. Teacher, pause the video, have the students work with their partner, and I'll meet you back here in a minute. Welcome back. Here's what I thought of. The benefits, why it's a positive, is it's visual. It's relatively easy to do, and it requires not very much algebra. But the challenges are it's not very accurate, and it's hard to do if the numbers are large or if they're very small. So if the graph is very, very large or very, very small, it's very hard to tell. It's not very accurate, meaning that if the numbers don't end in integer points, it's really hard to tell whether it's a half or a third. So there are some benefits and some challenges to finding where these 2 lines intersect. And now on your note taker, please do a 12-word summary of the most important aspects from today's lesson. And I'll meet you back here again for another math and construction lesson.